Hello everyone, today I'm going to show you 4 sorting algorithms using Python. And first, we'll start with the most infamous bubble sort sorting algorithm. I think it is the most basic sorting algorithm that is out there. So without further ado, let's start. First, we need to declare our function, bubble sort, which takes in an argument of an array. And then, excuse me, we are going to do an outer loop for each item in the array, and then an inner loop to compare each value. So here we start with 0, len array minus I minus 1. And then in here, we are going to compare if the current value is greater than the next value. And if it is greater than, then we essentially swap those values. So array j plus 1 is equals to array j plus 1 and array j. So we don't need to return anything for this function as we are going to mutate or change the values directly in our array argument or parameter. So for here, I'm going to declare a numbers array, which will be 27, 10, 5, 30, and 2. So here I'm going to call my bubble sort function against the array, and then we print the numbers. Again, we print the number and not the result of the bubble sort function, as we are directly changing our array or mutating the array, changing its values instead of returning a new array. So here I'm going to save and press run. And as you can see, 2, 5, 10, 27, and 30, which is sorted in ascending order. Thank you. Okay, so the next sorting algorithm is merge sort. So since the merge sort function is somehow complicated, merge sort algorithm is somehow complicated. I want to focus first on coding it and then trying to explain it as I go. So first we need to define the function and then let's go. So here is the key of the merge sort function. We are going to what do you call this? We are going to subdivide our original array into two halves, but it doesn't end there. We are going to subdivide it until we are remained with 1 unit, as denoted by this if check here. We only need to proceed in our merge sort function. We need to have one single unit, and then we incrementally sort our array and merge it to become a sorted array. So let me proceed coding. I is equal to 0, j is equal to 0, k is equal to 0. 3 iterators, and then so for the next procedure is we sort the left side first, and then we sort after the right side. Space here. So while J and R array K R J. And then after that, we declare our numbers array. Then we do merge sort numbers, then print numbers. As you can see, we have sorted 17, 19, 100, and 101 successfully using the merge sort array. So, as a summary, merge sort divides your array into until you have one remaining piece, and then you sort it with the adjacent nodes or adjacent segments of your array until you are returned with a sorted array through that process. Thank you. So the next sorting algorithm would be the insertion sort algorithm. So as per the merge sort example, I'm going to type away and then try to explain at the end. So insertion sort. Okay. So for I in range 1, right? T array I J um, I plus 1. And then here in this part we compare the value T array J array J plus 1 and array J plus 1. And then we is the last one. So here I'm going to declare my numbers array 9, 4. We're going to do insertion sort array and then excuse me, print numbers. Word. Array is not defined. I meant numbers here, sorry. Here, 13, 24, 28, and 29, which is successfully sorted in ascending order. So, for the explanation of insertion of sort, it is somewhat similar to bubble sort, in which we iterate linearly to the array. But in the case of insertion sort, we insert the least value back up to the array instead of the bubble sort case, which is going to switch each value per iteration. So that's all thing. So for our final sorting algorithm, which will be selection sort, I am still going to uh, write the code first and then explain after. So let us start. Def selection sort array size min 9 14 range 1 size, and then if the array j is lesser than I mean min mum, since min is a reserved keyword in Python somehow. Minimum. 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 There. Sorry. Um, minimum equals the value of j. And then we are going to swap values after here. So array array min minimum array minimum and array I mean j yeah, nothing. Here we declare our numbers array. I'm going to use the values of my last example, 13, 24, 28, 49, and then selection sort numbers, len numbers, excuse me, print numbers. So as you can see, we got the same result which is selection sort. So for selection sort, we iterate through the array and we remember the least value of our array. And then for each iteration, we set that least value, and if it changes, then we swap those positions, and then we repeat the process until we are finished with the sorted array. So that's all. Thank you.